Well, hello everyone. Good morning, good afternoon, good evening. Thank you for joining us for today's webinar featuring Bob Walker talking about common problems deploying to Kubernetes at scale. My name is John Bristow. I will be your co-host for today's webinar. Thank you for your time and attention. We really appreciate you joining us today. And I'll be kicking things off with just a bit of housekeeping before we get started here. So just to let you folks know, you are in the right place. This is a series of webinars that we'll be conducting over the course of the next few weeks, months, etc. And if you're wanting to find out more, you can go to our website, which is octopus.com/webinars. There you'll find registration links for all of our webinars, along with all the recordings of previous webinars. So you can see we've hosted a lot of these. We've hosted product webinars. We've hosted webinars featuring our customers, etc. If you're all interested, you can go ahead and check that out at octopus.com/webinars. In addition to that, as I mentioned, this will be a recorded webinar, so you'll find a recording up on our YouTube channel. Search for Octopus Deploy, you'll find our channel there. We post videos all the time. We've got all of our videos for our shows, etc., our webinars that we've hosted previously. You'll find them up there on YouTube, so feel free to check those out. In addition to that, we'll be talking a lot about Kubernetes in this webinar. If you're interested at all about how we support Kubernetes from a deployment perspective, you can read more about this at octopus.com/Kubernetes. There you'll find information about how we support Kubernetes, all the features, and the functionality that's built into Octopus Deploy if you're all interested. And then finally, last but not least, you can join our community. We have a Slack channel with over 6,500 members. You'll find the link for this at /community off of the Octopus website. And there you have a lot of folks like yourself deploying with Octopus, and we would love to see you there up on our Slack channel, so feel free to join. Great. Awesome. So as I said, Bob will be talking to us about deploying to Kubernetes. Thanks for joining us, Bob. We really appreciate it. We'll go ahead and turn things over to you.
Awesome. Well, thank you for having me, John. Thanks for that fantastic introduction. That was very high energy, considering the time of day it is for you. So good for you on being that up at 5 a.m.
No worries.
Yeah. So as you said, we're going to be talking to you about common problems with Kubernetes deployments at scale. I want to start off with what you're going to learn with this webinar and how it's going to benefit you. So this webinar is broken up into 3 parts over the next hour or so. First, we're going to talk a little bit about common Kubernetes deployment approaches. I'm not sure of everyone's familiarity with Kubernetes that's watching this particular recording, as well as this is going to be recorded in the future, and I want to level set everyone. And that way we have a clear understanding of what a Kubernetes deployment entails. Then we're going to start talking about some common scalability problems. And I really want to make sure you can identify anti-patterns and pitfalls early. I hope you pick Octopus Deploy to solve those issues, but if you don't, at least be able to identify those problems before they become a significant issue and you spend weeks, if not days, trying to rectify it. And then this is an Octopus Deploy webinar, so naturally I will be showing you how to resolve these issues using Octopus Deploy. Sorry, I have to click around a bit. All right. I want to set a couple of definitions for this particular webinar, mostly so we can, again, all be on the same page. You're going to hear the term manifest files, or I'm going to say manifest files a lot over the next hour or so. Collectively, when I say that, I'm referring to customized overlays, manifest files, Helm chart templates, anything that's the YAML files that we're going to be sending into Kubernetes. I mostly did that so my slides didn't look like this massive wall of text. I just simplified it that way. The next thing is when we talk about Kubernetes at scale, there's a lot of different ways that you can take it. And so what I'm focused in on primarily is deploying a lot of applications. So that's the type of scale I'm referring to. Either you have a lot of applications on a few clusters that have a lot of nodes, or you have a lot of applications going out to a lot of clusters. Or you might even have a few applications, but each one has hundreds or even thousands of copies. So maybe you have thousands of Kubernetes clusters, one per branch office or restaurant or something along those lines. Regardless of the approach, I'm really focused in on doing dozens of deployments per day per application. And so what we're going to be focused primarily today on is how do we get those updated manifest files? See, I already have that in there. to those Kubernetes clusters. So we're really going to be focusing on this particular problem, solving this, where we have these manifest files stored in Git and how we're going to get them to Kubernetes, because we've solved this last little bit, but there's a lot of extra stuff that goes on top of it. So let's first talk about some common Kubernetes deployment approaches. And again, I'm not quite sure of everyone's experience with Kubernetes, so we're going to start with the very, very beginning. And what I like to do is I like to compare virtual machine deployments to Kubernetes deployments, specifically if you're not very familiar with them. So when I say we're going to deploy to a virtual machine, in a lot of ways, it's a lot like telling a 5-year-old to make you a peanut butter and jelly sandwich. You have to give them very explicit instructions at very specific time. Otherwise, you can end up with a situation where you get a sandwich that has jelly on both sides of the bread, and just as a joke, or you end up with a peanut butter and jelly burrito, and who knows what could happen. And so you have to be very, very particular. Now, when you deploy to Kubernetes, it's a lot like telling an adult, hey, I want a peanut butter and jelly sandwich on wheat bread with some smooth peanut butter and raspberry jelly. And you can walk away, get a drink, whatever the case may be, and then you can come back and you're going to have a sandwich. And you know you're going to have that sandwich because you trust the adult that they're going to do that for you. And the way that Kubernetes does this is they leverage desired state. And the best example I like to think about is the thermostat in your car. So you can set your thermostat to, say, 70 degrees Fahrenheit. That's what that example's for, not Celsius. You're not dying in the car. And what the thermostat will do under the covers is it's going to be constantly checking on the temperature. And if it's below the desired temperature, it'll increase the heat. If it's above the desired temperature, it will decrease the heat by introducing air conditioner. And so when you're deploying to Kubernetes, there's really two big ways to do this. So there's the CLI, commonly called kube control or kubectl, whichever side of the fence you fall on with that definition, as well as the raw manifest files. And the raw manifest files are typically the most common way as opposed to just using the command line. And then we have wrappers around those manifest files that customize in the Helm charts. But ultimately, you end up with a manifest file you then give Kubernetes to go ahead and run for you. So again, I want to show off a quick demo of what a manual Kubernetes deployment would look like. So what I have set up, let's jump over to this one, is I have a manifest file and I have a very particular application. I'm pretty sure the last version was 0.1.66. And so what I want to make an update or do a deployment, I would come in here and I would update the image tag that I want to deploy. In addition to that, I would also specify the resources such as memory and CPU, any sort of ports that I'm going to be running on, any sort of secret phrases, anything like that. And so this manifest file, this is what I'm going to be giving to Kubernetes, and then Kubernetes is going to figure out the rest for me. So I can come into my command line, and I can go ahead and do a kubectl apply. And I give it a file name. I'm already in the directory, and we can see here that one thing was configured, and then we had two other items that were unchanged. And so now we can check to see the deployment, see how well it's going. It says the random quotes deployment's looking good, and I can check my pods. And I can see that it is running. That means I copied in that version number correctly. And if I were to go to the application, I could see then, fingers crossed, I'm running 0.1.66. And it's as easy as that. Not a super hard thing to do. So those of you that are watching this webinar, it's 9 minutes in and all I need to do is just run kubectl apply. Why is that so hard to scale? The difficult thing is that something needs to get that updated image information to Kubernetes. I happen to know it was 0.1.66 just because I've been running through this demo a few dozen times. But not everyone's going to know that. So let's examine a common Kubernetes pipeline that we'll typically see out in the wild. And so again, we have our manifest files, and they're typically going to be stored inside of Git. And then we have something from Git pushing that file to Kubernetes. But those manifest files, they're not storing the actual images, they're just storing the image tags. The actual images are going to be stored in a container registry, Docker Hub being the most popular one. And so the actual image itself, say in our case version 3.4.2, that's running in the container registry, and I need to somehow update the manifest file, which then I can then apply to Kubernetes. But there's a whole other pipeline on top of that, and that's to update the container registry itself with the latest version. And so we have another pipeline built on top of this, and this is your CI pipeline. And so you have your build server, and it's monitoring your source code. It could be C#, JavaScript, Java, Python, whatever the case may be. And your build server is monitoring it, sees any sort of changes, builds it, creates the image, performs the appropriate tests, and then assuming everything passes muster, then we will go ahead and push the newest version up to the container registry. And so now we have version 3.5.1 pushed up there. But something needs to get that version from the container registry into our manifest files. And that's why I have this dashed line, because there's not really a direct connection right there. Now, you could leverage something such as a GitHub Actions or Jenkins or a pull request or any other process that's out there to go ahead and copy that version 3.5.1 down to your manifest files, which then it will see that, and then we can push that up to Kubernetes, and then Kubernetes will see that. And so there's a question as to what's going to be responsible for updating those manifest files and what's going to be responsible for pushing those changes from your manifest files to Kubernetes. And very commonly, we'll see Argo be one of the approaches to do that, where Argo is installed on a Kubernetes cluster and it's configured to monitor a particular Git repo and typically a particular folder, such as like a dev overlay file or a staging overlay file, or it could just be monitored in the manifest files directly. And when it detects a change, it will automatically apply that change to the Kubernetes cluster. So that takes us onto a brief detour into GitOps. And if you're not familiar with GitOps, I'm going to give you the TLDR version of GitOps. There's much more documentation. There's plenty of books, plenty of resources out there. This is very much the highest of high level that's out there. So the very first thing is that GitOps, that the entire system, your application, has to be described declaratively. And this is why Kubernetes and GitOps works hand in hand with one another, because it's really, we need to define the desired state. And as you know, we're already dealing with desired state with Kubernetes, which is perfect. So we meet the first criteria. The second thing is that that desired state file needs to be stored someplace, some sort of state store, which is commonly Git. And that's where we get the term GitOps. But that means it has to be versioned, and you're storing that information inside of Git again. And then once that file has been updated, you have some sort of system that automatically applies those changes to your application host. Now, it's very particular, and I was reading through the documentation. They use the word automatically and not instantaneously. And so there's a big difference between instantaneously and automatically, because it's more of it could be delayed by a minute or two or a couple seconds or even 15, 20 minutes, depending on the system. And then finally, it's continuously reconciled. And so software agents ensure correctness and alert on any sort of divergence from the desired state. So you might be thinking, I'm going to be here bashing on GitOps for the next hour. And I couldn't get any farther from the truth, because I love the concept of GitOps. I love the fact that we are moving towards that desired state like this. I love the fact that it's restoring that desired state of how we want to host our application in the same Git repository as our application, where we're also storing how we build the application and how we deploy the application. And so now we have how we build it, how we deploy it, and then how we will host it. And that makes things so much easier. And I love the fact that it's going to be automatically approved. It's going to be automatically applied, not approved. And then we're also reconciling it. And so if you're leveraging something like Argo and you want to also use Kustomize, what it would typically look like in this approach is we have our raw manifest files. And then we'll have a different configuration per environment. So we have our development config. And then within, say, a tool like Argo, we'll have, sorry, I forgot about the production, staging, and test config. And then we also have config files for each of the other environments. And then leveraging a tool like Argo, we'll have a dev application inside of Argo. It might be on the same cluster in a different namespace or a completely different cluster. And then Argo is responsible for doing that syncing between the two. And we'd have the same for each of the other environments that we have within our application. Maybe you have 3 environments, maybe you have 2, maybe you have 5, maybe you have a lot more than just the 4. I think it's funny that every company that I've worked for, we somehow landed on 4 environments independently. We call them the testing and staging. They're always completely different, but dev and prod seem to be the only constant. And so let's say I have version 3.5.1 that I want to then progress through to production. Well, the very first thing that I would do is I would update my development config file, and Argo would see that, and then it would automatically apply that to my Kubernetes cluster. And then I'd do the same thing with test. And that would automatically sync up, and that would be applied to Kubernetes. And we repeat the same thing for staging as well as production. And so what Argo is doing is it's providing that type of functionality for us. And so the demo that I'm going to be showing off is I'm going to be leveraging Argo as well as a manifest file and GitHub Actions to handle that for us. But I did set myself a bit of a challenge because I started thinking about, for a demonstration, what would be a common, say, branching strategy that I would want. And so it's very common for someone to have the main branch, and the main should always be ready to deploy. And I'm doing all my work inside of feature branches. But as I'm checking in changes to that feature branch, it would be great if I could automatically push that up to development. That way I could get feedback faster, I could determine what's going on, I can talk to the, say, business owner or the product manager or whomever and start getting that feedback. Is this what you want? Am I getting close? Are things looking good? Any number of those different things. And then once I'm ready, then I'll submit a pull request into main, and then that will then start the progression to test, staging, and then production. But one of the challenges that I ran into when I first set this up was that it was super easy to configure Argo to look at the main branch. Just point at the head on the main branch or the default branch, and it will automatically, monitor that and look for any sort of changes. But for dev, that feature branch, that's changing all the time. And so with Argo, what you can configure is you can configure it to look after a tag or look at a particular tag. And that's what I have configured within my Argo application. I have 4 applications configured, one for each of the different environments. I have dev, test, staging, and prod. And unlike dev, test, staging, and prod, I'm looking after dev Argo. That's what I'm checking out. And then for prod, staging, and test, it's looking at the head. So it's looking at my default branch, whatever the latest commit is, go ahead and push that up. But one of the challenges I ran into, and what we're going to see in a second, is updating that tag to the latest version proved a little bit trickier than I thought. So let's go ahead and I'm going to commit a change that I have ready to go. And I'm going to go ahead and push this up to my dev branch or my feature branch. So let's go ahead and push this up, and this will kick off an action for us. And so let's take a quick look at what that action looks like. And if you're not familiar with GitHub Actions, that's perfectly okay. I'll highlight some of the key things that we need to know. But obviously, there's going to be some syntax in here that's probably going to look a little goofy to you, and that's perfectly fine. So the first thing to make note of is that I am in this process, it's calculating the version for me. And that's really important because then I'll know the version later down the line. Because that version, from this determined version inside of here, that's what I'm passing into my build arguments, as well as when I push this up there, that's what I'm tagging my image with, is this semver that it's spitting out. But since I know that version, after I'm done pushing this Docker container up to Docker Hub for me, then what I'm doing is I want to update my dev or my test overlay file depending on what branch I'm in. And so what it's doing here is it's doing a path for me, and then it's going to be setting it to this semver. And so what that looks like is I'm telling it to go ahead and update this new tag, this version right here, to whatever the GitHub action calculates for me. And then I have a bit of logic that sits here that says if I'm on the main branch, then go ahead and update the test file. If I'm on any other branch but main, go ahead and automatically update the dev file for me. And since I just updated that file, I need to commit it. That way Argo can see that that file has changed. And so you'll see here that I have a bunch of work that's going to come in here, and it's going to commit that change to my Git repo, and then it's going to go ahead and push that up. But when I'm not on main, I'm also running a bit of a quick check, and then I'm going to update the tag. I'm going to say update it to the latest commit that I just had up here. So let's go back to GitHub, and we can see that the demo commit has finished while I took that long to explain what was going on. And we can see, that's nice, it only took 57 seconds. And we can see the update customize overlay. Oops. We can see that we've updated to 0.1.70 demo.1. And then if we come into Argo, we can see that it's picked up that change. And we can see now that it is pulling down 0.1.70 demo.1. So when I want to then commit to test, let's go ahead. Let's say when I want to progress this to test. Let's say everything's looking good. Probably not as in the middle of the deployment, but for demos purposes, let's go ahead and compare and do a pull request. And this is a fork repo, so I have to check around a couple things, able to merge, happy days. Let's go ahead and create the pull request. And I'm going to go ahead and merge it. I'm full on corrupts today. I'm just going to go ahead and merge this into my main branch. And then what that's done is, again, it's kicking off another action for me that's merging the pull request. And what, again, it's doing is the exact same thing that it just did, but because I merged into my main branch, there might be other changes that I needed to merge. So I need to do a fresh build for test. And then that is going to be the container that I'm going to progress through from test to staging to then production. In terms of what we ran earlier, it's going to be the exact same steps, but the big difference is now this condition is true. And so I'm updating the test customize file, and then I'm going to be skipping over these particular steps on this. And so hopefully this finishes up fairly quickly. So it's pushing the container right now, and we should get a new version fairly quickly. So I'm on 0.1.72. That's the new version that's being pushed up to GitHub right now. You just have to learn how to read these things really fast. I've only done this demo a few times in preparation for this, so I'm able to look at these GitHub actions pretty quick. So now it's updated to 0.1.72. If I come back to Argo again, I can see Argo has, let's see what version we're on. It's still on 69. So I'm just going to refresh this. I do have it set to automatically sync, but sometimes I'm an impatient person, especially when it comes to demoing in front of a bunch of people. And I'm just going to say, go ahead and update this right now. And so now I can see it updating to 0.1.72. But let's say now we're ready to go to staging. And now we're kind of, the GitHub action that I've set up is only for dev and test. And so maybe what I'll do is I'll do something you're never supposed to do, which is checking a change directly into main. But I'm going to go ahead and do that because that's just the way I'm going to roll today. And I'm going to go ahead and update the file to 72. Now I could typically you'd be creating a pull request and go ahead and merging this into your main branch. You wouldn't be checking directly into main, but that's what I'm going to be doing right now. 272. Let's go ahead and commit these changes. And so now I've updated this manifest file. And so now my staging application will pick up on that. I think it's still on 69. And I'm going to go ahead and refresh this. And it'll pick it up and it'll say now, okay, now we're going to pull down and run 72 for us. So that's what the deployment will typically look like with Argo. It's important to note that Argo is just the means to get the updated, I would say the updated manifest file into Kubernetes. But I could easily have replaced that Argo with doing kubectl apply in that same GitHub action if I chose to do that and not mess around with committing those changes. Or I could leverage Jenkins to do the exact same thing. Or if I wanted to, I could also leverage a Helm chart to handle that for us and have a GitHub action call out to that Helm chart. The biggest takeaway here is that something needs to update the manifest files and push them to Kubernetes. And GitOps helps getting the updated manifest files to Kubernetes. And so when we talk about GitOps, oftentimes it's focused in on those last two items in this particular pipeline when we come back to this diagram. Those are the two things that it's really helping out with. Okay, so we've talked about this for a little while. I'm going to stop before we move on to common problems to see if there is any questions on this.
No questions yet, Bob.
Okay.
Some people have said that there's some blurriness to the screen. I think if you have a chance to pump up the zoom, that'd be greatly appreciated.
Yeah,
Thanks.
yeah, not a problem. I can absolutely do that for the next demo. All right, awesome. So GitOps is a great concept, and I'm not going to bash on that. I love it. I think it's fantastic. But I think it doesn't prescribe a solution for updating those manifest files. And this is intentional because GitOps, while it's typically associated with Kubernetes, it also can be used for updating your cloud infrastructure or even your virtual machines. But as long as all the rules apply, we have the desired state, we're going to have it automatically applied, and everything like that. And so when we are focused in on that, we want to apply the changes, say using Argo. And I had to set this up where I have a slightly different way of doing my deployments. So I'm monitoring a tag on development. I'm monitoring my main branch. That's a slightly different approach for each of these. But I don't know if you also picked up on this, is that this was automated when I went to dev and test. But then when I went to staging and production, I almost had a completely separate workflow that I was going through. Yeah, the end result was the same, where I updated the file and then I got it to, and then Argo picked it up and it deployed it to my staging namespace or to my staging cluster. And same thing with production, it would pick that up as well. But again, these are two completely separate processes almost. I have the automated and then I have the manual bits. I also glossed over the fact that there's a lot of knowledge, especially when you're getting started with Kubernetes, just to deploy that single application. You're going to have to familiarize yourself with the concept of pods and replica sets and how to do secrets and store those appropriately. How are you going to get access into the pod or into your running application? Are you going to use a load balancer, a cluster IP, or a node port? How are you going to handle ingress? What's a deployment look like? Because Kubernetes has a concept of deployments that's slightly different than the standard deployment that you're familiar with, as well as services, service accounts, and tokens, and RBAC and controls. And this was, as I was setting everything up for the very first time months and months ago when I was going through Kubernetes and I said, I want to learn how to do Kubernetes, quote unquote, the hard way with just raw manifest files. I had to learn all of this stuff just before I did my very first deployment. And then when we add in environments, things get a little bit trickier. And so first off, we kind of have an inconsistent solution when in updating the manifest files. Some of the processes, it might use a GitHub action to update, say, the lower environments, whereas other processes might leverage a a pull request to do that. And I bet that those of you that are watching this probably are thinking to yourself, well, why did he set it up this way? Why did he go down that route with using GitHub Actions? We solved it this way using Jenkins, or we have our GitHub action not messing around with updating the customized overlay files. We having a calling out to the Argo webhook, or any number of those different things. I think it's just important to point out that there are a lot of different solutions to updating those manifest files. And I would argue that chances are they might be inconsistent within the same application, and maybe even within the same organization. And that's a little scary to me. And then we have to worry about how are we going to find a solution that satisfies all of the environments, that can work for everything. Because again, we have the inconsistent solution. How are we going to make sure that we handle our environmental differences, those secrets, appropriately? Oops. And how do we deal with RBAC and controls? Because as you saw, I was an admin in my Git repo, and so I could go in and I could turn off all the branch protection policies and do whatever I wanted on that. So how do we handle those RBAC and controls? Because really all I needed to do was check into main, and I could have updated my production application right then and there. Yes, I was following my own rules for dev, test, staging, and production, but how do we know that the workflow is always going to be followed that way? Not only that, what version is in each environment? And this is one of the things that I've kind of struggled with when learning and going through Argo, is that I haven't found a good way to know what version is here. I can click in here and I can see the running tag. And if I wanted to, I can come into here and I can pull down the latest version. And I can see, okay, we've updated the test overlay file here and everything along those lines. I'm going to see if I can bump up that resolution a bit. Oh, view's not working. Okay. Okay, Zoom just decided not to work at all. So I'll just skip over this part really quick, but I have to look at my Git history for that. I'm going to see if I can bump up the zoom level a bit on this. So yeah, what I was referring to is finding the version tag. Ooh, that's coming at you. And seeing this version that's 0.1.70 demo 1. So what versions in each environment for every one of my applications? The other thing to consider is that oftentimes the container running on Kubernetes, that's one component of an application. And so we leverage, for Octopus Cloud, everything is hosted on Azure. So for every Octopus Cloud instance, that's a unique container running in a Kubernetes cluster. But as a company, we decided to leverage the hosted services, such as Azure SQL and Azure File Storage, for the other components of our application. Yes, we absolutely could have hosted SQL Server inside of AKS. There are definitely containers to do something like that. But in doing so, we basically said, okay, now we're going to become DBAs. And we decided to opt for the professionals to manage that for us. And we get a lot of other services on top of it. So we didn't have to worry about managing all that. We can leverage just worrying about getting the container running in Kubernetes and making it the best possible experience. And same thing with file storage. You can absolutely have some file storage in AKS, but we opted to leverage Azure File Storage for all of that. So we have all of these different components for an application. A Kubernetes cluster is just one application host. And so you might be leveraging Azure, you might be leveraging AWS, so you might have RDS, S3, and Route 53 for your data storage, your file storage, and your networking. Or you could have something on-premise, any number of those different things, but you need to be able to update all of that as well. So what's going to be responsible for updating that? On top of that, as I was going through and learning about Kubernetes, I found myself frequently having to dive into the logs and figure out what's going on and why something wasn't running. I thought something would be running, and I needed to have the ability to get into the cluster and start poking around. And I would see, oh, it's because the I fat fingered the version number or something like that, and it's trying to find a container that just doesn't exist. But in a production style environment, how am I going to get access to do that type of debugging? I probably would have to get kubectl access. Then you have to worry about giving developers the appropriate permissions to the appropriate namespaces and clusters and everything along those lines. And if you have a single application or a dozen applications, this isn't a tremendous hurdle to overcome, any of those. But when you start talking about 30 applications, it can get quite unwieldy. If we talk about just sheer customized numbers, we're talking about updating, I think it's 120, if I'm doing the math correctly, 120 different customized files we have to worry about. How are we going to update all of those? Now imagine 270 applications. You might be asking, why 270 applications? Why not 300 applications? This is as many times as I could get this screenshot to appear on this particular slide deck without Google Slides just throwing an absolute fit at me with doing that. But when we have 270 applications, now we're talking about having over 1,000 customized files that we then, or overlays that we have to worry about updating and everything along those lines. So just thinking, when we start talking about scale, as we start adding on more and more applications, especially if you're adopting, say, microservices, that was where things become a little bit more unwieldy. And so as people who are, say, platform engineers or DevOps engineers who are responsible for building out these processes and these pipelines, you probably have a lot of questions floating around in your head. How can I have a consistent process for all of my development teams? I remember when I started automating deployments for databases, and one of the things that we ran into was getting everyone to buy into a consistent process. The DBAs, they're really pushing for the automation of database deployments. But what they said was, the reason why we're pushing this for so hard is because it's like the Wild West out there. Every team has an inconsistent process of how they want to deploy to staging and production. Not only that, it's every application is completely different because the team might adopt a process and then later on go, that's not the process for us, or they just never retrofitted the other applications. So some of the other problems that we might have in terms of scalability is, what's the best option for those environmental secrets? How do we make sure that we pick something and have it be consistently applied? So for example, if you have HashiCorp Vault, you want to make sure that everyone can get access to that and everyone's leveraging that appropriately. And maybe as a company you decide to not leverage environmental variables, but you want to maybe do a sidecar pod or anything along those lines. How can I ensure concerns from all roles are addressed? Because oftentimes when you create a process, you might just be thinking about the developers and the lead developers, but you might have to worry about your auditors and your security people, as well as QA, making sure that they can easily get the latest version of the application. How can I ensure that I have something that's going to work for our support engineers so they know what version's out there? How do I know the deployment status for all of my applications in each environment across all of the clusters? And how do I enable developers to troubleshoot applications without giving them all kubectl access to all of the different clusters that are out there? And not only that, then finally, if I'm working on an application that has a lot of different components, let's go back to the Octopus Cloud example, where we have the cluster, and then we also are leveraging Azure SQL as well as Azure File Storage. How can I make sure I'm deploying changes to all of those concurrently and not just one application? So again, this is an Octopus Deploy webinar. So I'm going to walk through how Octopus Deploy can help solve those problems for you. So again, GitOps is a great concept. And so this is a common Kubernetes pipeline with environments. But we can break this down to basically 3 different problems. Environmental progression. How can I get those application changes to production? Observability. How can I watch those changes progress through to production? And then compliance. How can I make sure that those application changes are approved for production? So all the pieces are there, but something is missing, and I bet you can probably guess what I'm going to say. There's not a big mystery here. This is where we talk about Octopus Deploy. So Octopus Deploy, it's going to sit between the manifest files that you have as well as the container registry. And what it's going to do is it's going to take the manifest files, it's going to take the image from the container registry, it's going to take the deployment process that you define as well as any variables, and then it's going to snapshot it. So when we want to create a release, we can go ahead and push that out there. And so we're going to be leveraging these types of features to help solve a lot of these different types of problems, where we define a single process for all components. We're going to leverage releases that we can then promote through the different environments, as well as audit logs, SIEM integration, ITSM, and RBAC controls. I'm not going to spend a tremendous amount of time demoing that, just because the demo, it looks a bit goofy when I start logging in and logging out. But we have other webinars out there and other recordings that walk through how to set up ITSM integration, such as with ServiceNow, as well as how to do RBAC controls. And then we also have runbooks as well to provide those day 2 maintenance tasks without having to give everyone kubectl access. So when we want to deploy version 3.5.1, we'd create the release in Octopus Deploy that would marry all of those different pieces together. We would then deploy to dev. And then when we want to go to test, we could push a button. And then when we want to go to production, we could push another button. So let's focus in on the demo for Octopus Deploy. All right, so let's go into, first I'm just going to commit something really quick to trigger this. What I'm changing doesn't really matter. I'm just triggering a commit to trigger my action. All right, so let's get into here. Let's see if I can zoom this in a bit. I'm using this isn't a virtual machine, so I'm not quite sure if my keyboard mapping is all 100% the same as it goes through. So I decided to use the UI, a little bit of click ops here. Now I did set up myself another challenge where this is deploying to components outside of Kubernetes, because I have a database that's running on SQL Server, as well as a container running in a Kubernetes cluster. But there's still a lot of overlap between the two. So we have the same thing as before, determining the version, we're calculating all of that. And then I'm doing something a little bit different here. And this is more just me being very particular about my version numbers. And so I'm building up the version number using that information. You don't have to do that. This is just me, again, me being me. But I'm packaging up the database. But then outside of that, it's a lot of the same overlap here, where we're logging into Docker Hub, and then we're going to build and push that website container. Nothing super fancy. And in fact, if you looked at the build arguments as well as the tags, they would look almost the exact same. In fact, my very first demo, I forgot to update this tag, but everything else worked exactly how I wanted it to. The place where we diverge here is, well, I'm pushing up the database package because that's not a container, that's just a set of scripts. And I'm also pushing up some build information, and this is more, again, for a better experience. You don't have to do this. And if you just had an application that didn't have any outside components, we could easily have cut this out if you didn't want to do that. But the primary difference here is now we're creating a release. And we're following the same logic as before. When I'm in the main branch, I want to deploy to my my test staging and production. I want to deploy to that workflow. But when I'm in a feature branch, I just want to go to development. So let's see where we're at with our workflow runs. Okay, it took me a minute 44 to describe what was going on. That was intentional, but we did finish up with this GitHub action. And we can see that it created the release for me, 40.20.1. And if I come over to Octopus Deploy, we can see the version, and we can see that's being deployed right now. Not only that, I can see the version in each environment for all of my applications. So I'm going to come in here and I can see where we're at in terms of the steps. So right now, I'm having it go ahead and deploy my database changes. So it's running a runbook actually right now to make sure that the database is ready to go. And then after that, it will go ahead and deploy those database changes. And then I'm going to have it run a couple of steps to deploy my container. I'm going to update the secret for this application. That's the connection string back to the database. And then I'm going to go ahead and deploy the website. A couple of other things before I forget. I'm also leveraging our config as code feature. And sometimes I've tempted fate and things aren't working how I want it to work exactly. I'm using the config as code feature, and this is storing our deployment process in the same repo as our application, as our manifest files, as well as our GitHub action. I'm going to go ahead and I'm going to zoom in just a little bit just to make it hopefully a little bit easier for people to see. And so you can see all the steps that it's running for each of this. But again, I'm deploying all of the components of my application, both the database as well as the Kubernetes cluster as part of this. And then I'm leveraging variables to handle any sort of differences for me. So I might have a different database name per environment, as well as I'm going to have maybe different host headers, as well as I have different images and all that other good stuff per environment. And so this should have finished up. And one of the newer features that we've added last year was the Kubernetes object status. And so we can see step 7 created the secret, and there was no change there. And then when I deployed the website, I can see everything that was going on. And we can see this was the latest deployment that went out there, the status of the deployment, the service, and the ingress as well. And so if I wanted to merge into main so I could start going to test, let's say everything looked good, I would get the same experience that you're used to, where I could use a pull request to go ahead and merge all of my code changes. If I made any sort of deployment process changes, I could do that as well. And I'm going to go ahead and create the pull request. All I did is one small little change. And this will go ahead and merge that request for me. And so this will trigger another action. And this is just again, I have to rebuild it because I just merged into main. I might have had a bunch of other commits come into main in the meantime, and I want to make sure that I have a fresh build. But this is the last time I'm coming back to GitHub and I'm making any sort of changes or anything like that for this particular change. And so when I come to Octopus Deploy, once it finishes its action, then we can go ahead and it can do the promotion. We're actually going to see it start the deployments to test. But when we want to go to, say, staging for this, I'm just going to go ahead and skip ahead a little bit in terms of time. When I want to go to staging, I can go ahead and click on the deploy button here. But you'll notice I can't deploy this to production because I haven't gone to staging. So I'm enforcing those rules right there. So I'm going to go ahead and click on the deploy button to go to staging. And when I clicked on that deploy button, it was running through RBAC controls and is making sure that everything was appropriate and that I did have permissions to do this. Now, obviously, since I'm an admin, this is a demo, I'm going to have basically full rights to do whatever I want. But when you go to production or anything like that, those permissions, they could be very different. And I did mention we're also running a runbook to configure the database server. And that's just one use for runbooks. I also have a number of other runbooks out here that can describe the pods, get the deployments, get my ingress, get my pod logs, get the pods themselves, and get the information about that. But the key here is I'm not giving developers just raw kubectl access here. I'm providing a wrapper around that. And so I can get limited use production access, a very specific process that I've defined already. I can also do things such as scale out the pods to 1. Or I think there's another, oh, that was the only one I had. I had another one where I could scale it down to 0, but I think I just had to scale to 1 because that's what I was thinking about. It's like, that's ridiculous. But I could also do things like I want to run ad hoc scripts. So I get those types of permissions that are available. So again, we're coming back here again, we're looking to solve these types of problems, this environmental progression. How are we going to easily get these application changes to production? Observability. How can I watch those application changes progress through to production and then enterprise compliance? How can you ensure those application changes are approved for production? And then if there's any common day two maintenance tasks, how can I make sure that that's all working as well? And we covered a number of these different features. We have the single deployment process that we defined once and we reuse it multiple times. We have those releases that are progressing through the different environments. For enterprise compliance, we have the audit logs, the SIEM, ITSM, and RBAC controls, as well as we have runbooks. And so this is what a GitOps pipeline with Octopus Deploy will look like. The good news is that everything you've seen today, you can implement right now. The latest version has all of these features and functionality. But we do have upcoming changes. So go to octopus.com/roadmap and you can see some of these upcoming changes. I've highlighted a few ones here. We're working on in terms of active development, we have an Octopus agent for Kubernetes that's going to install directly into the Kubernetes cluster rather than leveraging a worker. I'm super stoked for that because that solves a big problem that I've run into in the past. We also can trigger release creation automatically on container image update as well as Helm chart update. So the idea being that we won't need, ideally, this step in the future and make it a lot easier for us. We can also, same thing, trigger release creation on a Helm chart update. So they're basically mirror images, just using Helm charts instead of containers. And I'm also super excited for that Octopus Deploy GitHub app. It's going to make some of the authentication process a little bit easier. So I'm really excited for all four of those things. And these are in active development right now. We also have items on our roadmap that are under consideration, what we call being shaped. What this means is we have a pretty good idea of what we want the solution to look like, but we're still working on shaping the final thing. And we want to get feedback and make sure that we prioritize that appropriately. So if you really want the Argo plus Octopus agent for Kubernetes resource mapping, I encourage you to go to the roadmap and upvote it. We also have we're also looking at monitoring Kubernetes resources beyond the deployment execution, as well as triggering a release creation on a Git update. And we're also looking to make the Kubernetes experience a little bit better. And in terms of things that we're researching, we're really looking into the concept of blueprints with guardrails. And so this is taking that whole concept of scalability into the next levels. So our product team, we're researching the vNext solution. If you saw some previous webinars and previous blog posts where we talked about Octoterra, what that does is it allows you to basically create a templated project, and you can then serialize that existing project or that runbook or the space to a Terraform file. And this is built by our sales engineering team, but the only thing that I would throw out there is make sure you understand how Terraform works. Don't just dive in there because you need to know how Terraform works around, especially around state management. Because basically once you start putting a project and say, okay, I want the Terraform provider to be responsible for it, any changes you make outside of that Terraform script or template are going to be overwritten the next time that it's applied. So that could be a little dangerous if you're making changes directly in the UI. So again, be sure you understand it. So that's our vNow solution for that. So that's it for now. I know I went through pretty quick. John, what kind of questions do we have coming in?
We've actually got a couple of questions. We have a scenario here that Raghunath has outlined here. We'll just briefly read it. We utilize a unified workflow for our CI job that constructs images, tagging them for various regions. Sounds like tenants. Mm-hmm. Our aim is to deploy these region-specific tags across production Kubernetes clusters in different areas. We're attempting to consolidate this process into a single repository that houses a template file, so customized comes to mind, which will be updated with image changes. However, we're encountering difficulties in synchronizing the YAML files and the images.
Yeah, that's a good question. So let me pull up Octopus really quick. And so this is the multi-tenancy feature that John was alluding to. And so what we have here is I have different tenants, and each tenant in this particular case represents a location or a store, or it could be regions or whatever the case might be. And each one has a different version that I'm deploying to, but they all share the same process inside of here. I'm not changing anything. I'm not swapping out anything depending on that. So I define this process once and I can reuse it multiple times. Now you mentioned the tags and updating everything like that and handling some of those environmental differences. And this is where the variables, specifically structured variable replacement, will come in. And I kind of glossed over this a little bit because it was kind of outside the scope of the demo, but I'll talk about this just ever so briefly. So you'll notice that I have this kind of weird syntax here: spec templates, spec containers, 0 images. What this does is I'm telling Octopus Deploy when it loads up my manifest file, which is here, base Kubernetes. I'm telling it to find this tag and go ahead and update that appropriately. I can tell it to find any of these other items as well. And I could also have different variables that I want to overwrite on some of that stuff. So I have a bit of flexibility on doing something like that. So I think hopefully combined those with those two things, it should accomplish a lot of what you're looking for.
Fantastic. So thanks a lot for the question. It's so much that my head barely gets around the question. So
Yeah,
there you go. Great question.
I had to unzoom my camera a bit.
Awesome. A bit of a challenging question here, but fair. So Naveen asks, how is this different from Jenkins? So this was asked during your demo when showing how to deploy via Octopus.
Yeah, that's a really good question on something like that. So a couple of things that I want to talk a little bit about is that we are built from the ground up to be a deployment tool. And so we have a lot of these concepts specifically around the concept of a release where we snapshot it. And that's absolutely critical. And again, I kind of glossed over that a little bit, but we snapshot the manifest file, we snapshot the version number, we snapshot the process, as well as we snapshot the variables. And so how I deploy to, in my case, test, staging, and prod, when I go to production, it's already gone through test and staging, and I know it's going to work for that very first time. The other big thing is we do have that concept of runbooks that work alongside the Octopus Deploy deployment process. And so really it's with that plus the RBAC controls, all three of those really combine to make it, like, in my mind's eye, the true difference. It's kind of like a tripod. You can definitely do one or maybe even one and a half of those things with some of the other tools, but it's all three of those things that you combine together that makes that true difference.
Yeah, based on my experience, I also find that the taxonomy that we define is much more featuring deployments more than anything. You'll see a lot of CI solutions that define environments, but that is basically as far as they'll go, and then everything is left as an exercise to the reader.
Yeah, and our primary goal is to make very complex deployments as easy as possible. Again, back to the DBA, he's like, all I want to do is I just want to push a button. I don't want to think about it.
That's fair. There is a question here from Lucas. Any news related to supporting multiple application configurations with structured configuration variables? So he references a blog post here, which I'm just going to quickly show. So there's a blog post here written by Rob Arez, who's a member of our team, talking about using variables for Kubernetes without breaking YAML. Bob, do you want to talk a little bit about this?
Supporting multiple application configurations with structured configuration variables. Yeah, this is. I'd be curious to know a little bit more about the scenario you're thinking of, but I know within the step that you can enable this, and you can also reference multiple files within that step. I think the only thing I typically run into is when you have kind of a conflict between the two paths. When you have like a lot of different paths that you're trying to overwrite. It can get a little dicey at certain times, so there hasn't been any news on updating that. But I do know the newer versions of Octopus Deploy. I think it was 2023.2, and I want to say that's when we did it, but don't quote me on that. Is when a lot of that work was put in there.
Yeah, so for those who haven't seen this blog post, Rob goes into the details here of how you can structure these things. So there's this option here specified on the step for labeling this as using structured configuration variables. Then there's a way of denoting these as part of this. So he provides an example of how to actually define this as part of your deployment process. So there are some limitations, as he outlines here, specifically things around Make sure you don't use specific types of characters, but other than that, you can certainly use those in the context of your Kubernetes deployments. So great question there.
Yeah, one of
No
the
updates as far as I'm aware.
yeah, well, the only other thing I would throw in there is that we added in the capability to reference the Docker container or the Docker that you wanted, the image that you want to deploy in the step now, the raw manifest file step. Previously, that wasn't there. I think it was the 2023.4 is when we added that capability. So it made referencing the latest version tags so much easier on something like that.
Great. Great. Awesome stuff. I don't see any other questions. I'm just going to wrap up here, folks. I'm cognizant of time. Just to let you know about the roadmap here that Bob mentioned earlier, you can find it at roadmap.octopus.com. Make this your homepage, if not a bookmark. You'll find information there. You'll also be able to vote as to how important these features are for you. And if you are so inclined, you can also submit your own ideas. So feel free to do so at roadmap.octopus.com. Just to remind you, this is part of a series of webinars that we run monthly/weekly all the time. We're running these. The next one is on March 7th. That's an Octopus 101 series. So if you haven't seen Octopus before, you'd like to kick the tires, feel free to join us for that. That's on March 7th. We will be posting more updates to this. And further to that, if you want, you can find out all about our upcoming webinars by signing up for our webinars newsletter. So if you sign up here at the bottom, this form will allow you to get notified of when new webinars are announced and how we'll see them. And finally, just to wrap things up, just to remind you, we will post a recording of this, a full fidelity recording of this video that you've seen with Bob and myself up on our YouTube channel. So search for Octopus Deploy up on YouTube. You'll find us there. Bob, with that, thank you very much. I really appreciate it. We do have one other question here. We'll just quickly show it here. Raganoff asks another question. When deploying a Spring Boot application image, I lack the ability to substitute files with variables from Octopus Deploy. I must seek an alternative method for configuration, such as using config maps and secrets. This is a challenge. Okay, interesting.
Yeah, I saw this. I think I've
Any
seen
thoughts
this
on
come
this?
through on our via support. Um, I'll have to double check to see what they were recommending because I was thinking about this as well, and I don't really want to contradict them. I'd have to do a bit more research before just answering this off the top of my head. I'm sorry.
No worries, that's fair.
Yeah.
I put a link, or rather, an email list, support@octopus.com. Let us know. Sometimes these things require a little bit of investigation, but thanks for your question. Anyways, Bob, thank you for your presentation. Wonderful stuff. Thank you for your time and attention on this webinar, and we will see you on the next one. Take care, everyone.
Thank you very much, everyone.